Hello friends, hearty welcome to you. In this session, let's look at one of the methods of integration, which is integration by parts. Integration by parts is generally used whenever we have to find out integral of product of two functions, and also some situations where we are unable to find out the integral by using one of the earlier known methods like integrals of some particular functions, or integral finding out by method of substitution or by partial fractions. Nothing is helping us out, then we will try to look into integration by parts and see can we solve it or not. So let's understand now what's the meaning of integration by parts, what is the formula I have to, and how to derive that particular formula. Now we know that integration is anti-differentiation, and we started our integration, if you remember, by saying that if d by dx of cos x is equal to minus sin x, then integral of sin x is equal to minus of cos x plus c. So we know that if you want to find out the integral of a function, then you have to find out which function derivative is this particular function. That function is nothing but the integral. Now suppose I want to find out the integral of sin x, I have to look for the function whose derivative is sin x. That's nothing but minus of cos x. So that is how we have found initially by using differentiation to find out the integral. So we will try to leverage the same logic which we have used in derivatives, that's a product rule, and see can it help us to find out the formula for integration by parts. Now we know that product rule says that if you want to find out the derivative of product of two functions u into v, then we know that it's nothing but u into dv by dx plus v into du by dx. This is what we know. Suppose I have to find out the derivative of x sin x, I will say x into derivative of sin x plus sin x into derivative of x. That is what we know. Okay. Now how we can leverage this to find out the integral, or to find out the integral of product of two functions? For that we will try to apply integral on both the sides. We will say integral of d by dx of u into v dx is equal to, we have integral of u dv by dx that's u into dv by dx plus integral of v into du by dx into dx. Now we know that whenever we apply differentiation on top of it integration, we know they will cancel out each other. So we will have u into v is equal to integral of u dv by dx plus integral of v du by dx. Now we are interested in finding out the integral of two functions, so we will do a small substitution here. We will say that this is my first function and this is the product of function for which I want to find out the integral. So I will say let take u equal to f of x and dv by dx equal to g of x, so that we can say that I want integral of these two functions. Now what is the formula I have to find out? So if we go to the next step, we will write it as, we will try to take it to the left hand side. We will have integral of u, that's nothing but f of x, into g of x dx is equal to, so this part is equal to remaining will go to the left side, so I'll have u into v. If u is f of x, so u is f of x multiplied with v. Now dv by dx is gx, then v will be how much? If dv by dx is gx, then v equal to integral of g of x. We know that if dv by dx equal to g of x, if you want to find v, you have to do antiderivative. That means you have to do integration on it. So it will become integral of g of x dx. Then after that we have minus, because we just kept it here and we took over this to the left hand side. So we'll have minus of, again I have a integral. Then after that I have v into du by dx. What is du by dx? If u equal to f of x, then du by dx is equal to f dash of x. If u equal to f of x, then du by dx is f dash x. So I can go ahead and write it as f dash x and multiply that with v. V is nothing but we just know integral of g of x dx. So that is the formula to find out the integral of two functions. Let's go to the next step. Let's write it one more time. So we want to find out the integral of two functions. Let us say f of x and g of x. Integral of f of x multiplied with g of x dx is equal to, according to us, what we found out just now. You take the first function, leave it as it is, then take the second function, do integral on that, then say minus, then you have a big integral there coming, integral, then whatever the functions you have left earlier, now differentiate it and multiply that with whatever we got the integral of second function. So can I simplify that and say that integral of 1 into 2 dx is equal to 1 integral of 2 minus integral of 1 dash into integral of 2. Integral of 1 into 2 is nothing but equal to 1 into integral of 2. So we have to identify which function is first function to be left alone in the first step, and that needs to be differentiated in the second step. So integral of 1 into 2 equal to 1 into integral of 2 minus integral of whatever we have left earlier, that we need to differentiate. Then after that we have to do the integral. So let's look at one example and try to understand this.